Assalamualaikum and hi, I'm Unku Nadia and my friend Siti Noshazra, Muhammad Zulhafiz, Hafizullah Nazmi and Aina Natasha from Group 5 want to present about photon energy, photoconductive effect and photovoltaic effect. Photon energy is the energy carried by a single photon. The amount of energy is directly proportional to the photon electromagnetic frequency and thus equivalently is inverse proportional to the wavelength. The higher the photon frequency, the higher its energy. Equivalently, the longer the photon wavelength, the lower its energy. Photon energy can be expressed using any unit of energy. 1 joule equals 6.24 multiplied 1080 spectrum volt. The large unit may be more useful in donating the energy of photon with higher frequency and higher energy, such as gamma ray, as opposed to lower energy photons such as those in the radio frequency region of the electromagnetic spectrum.
For the formula of photon energy, we have E equal to HF, but photon energy is directly proportional to frequency, so we got the E equal to Hc over lambda. E is the photon energy, joules, lambda is photons, wavelength, meters, c is the speed of light in vacuum, and h is the Planck constant. In electron volts, energy is often measured in electron volts. To find the photon energy in electron volts using the wavelength in micrometer, the equation is approximately E times electron volt equal to 1.2398 over lambda times mu m. This equation only holds if the wavelength is measured in picometers. The photon energy at mu m wavelength, the wavelength of near-infrared radiation is approximately 1.2398 electron volt. Next, the application of the photon energy. First, the FM radio station. A 100 MHz FM radio station transmits electromagnetic wave that result in the production of photons with an energy of about 4.1357107 electron volt. From the mass energy equivalency, we know that this energy is around 8.1013 times the mass of an electron, or 9.1 times 1031. The next application is photosynthesis. A specific chlorophyll. Molecules absorb red light photons at a wavelength of 700 nanometer in the photosystem.
I will continue the presentation. First, I will talk about photoconductive effect. For introduction, in the photoelectric effect, electrons are emitted from a material when light is incident on its surface. Ordinarily, an electron is bound to the material and cannot escape from it unless energy is supplied. The light must supply its emitted electron with sufficient energy to escape from the surface. To be emitted from the surface, an electron must receive a minimum amount of energy F, called the work function of the surface. The value of the work function depends on the material and on the condition of the surface. And then I will talk about characteristics. For a characteristics, I have two types. First, the absence of the lag time. When radiation strikes the target material in the electrode, electrons are emitted almost instantaneously, even at very low intensity of incident radiation. This absence of a lag time contradicts our understanding based on classical physics. Second type is the presence of a cut-off frequency. For any metal surface, there is a minimum frequency of incident radiation below which photocurrent does not occur.
Okay, next I will continue about the advantages and disadvantages, then with the conclusion. The advantages of a photoconductor. First, these are cheap and available in different size and shape. Second, they need less power and voltage for their operation. Lastly, these are used to make simple circuit. The disadvantages of a photoconductor. Once applied voltage increase the maximum voltage, then it will cause damage to the photoconductor. Its response time is very slow, like 10 seconds or 100 milliseconds. It is sensitive to temperature and these characteristics are non-linear. In a conclusion, the maximum kinetic energy of photoconductive at the metal surface is the difference between the energy of the incident photon and the work function of the metal. The work function is the binding energy of electron to the metal surface. Each metal has its own characteristic work function. That's all from me. Thank you.
Photovoltaic effects. The photovoltaic effect can be defined as being the appearance of the potential difference or voltage between two layers of a semiconductor slice in which the conductivity are opposite, or between a semiconductor and a metal, under the effect of a light streaming. The photovoltaic effect is a process that generates voltage or electric current in a photovoltaic cell when it is exposed to sunlight. It is this effect that makes solar panel useful, as it is how the solar cell within the panel converts sunlight to electrical energy. The photovoltaic effect was first discovered in 1839 by Edmund Barker when doing experiment involving black. He noted the voltage of the cell increased when its silver plates were exposed to the sunlight. For the process, we have three processes. Number one, when a PV cell is subject to the sunlight, that absorbs amount of light generate electric energy, while remaining sunlight can be reflected a phase through. Number two, the electron in the atom of the PV cell are energized by energy of the absorbed light. With this energy, this electron move from their normal position in the semiconductor PV. Last one, material, and they create an electric flow, that is electric current, to an external electric current connect to the PV cell terminal. There are three advantages and three disadvantages of PV. Advantages number one is environment friendly energy. Number two, reduce your energy bill. Number three, infinite energy. For disadvantages, number one, seasonal energy, installation requirement, location sensitivity. Photovoltaic effects. The photovoltaic effect can be defined as being the appearance of the potential difference or voltage between two layers of a semiconductor slice in which the conductivity are opposite, or between a semiconductor and a metal, under the effect of a light streaming.